Hello everyone, welcome back. So in this video we are going to understand LeetCode problem number 120, triangle. So the question is saying that we have to return the minimum path sum from the top to bottom when we have given an triangle. Let's suppose for this example we have given the triangle, as you can see here, right? This is a 2D grid, you can say that we have given in such a way that it look like a triangle. Okay, but we have to find the path. Let's suppose if we'll start from here, right? So in the next row, right, we can say if this is I, we can say this is I plus 1, right? For the row, you can say, yeah, we can say row 1, row R, we can say, and we are going to do R plus 1. So each time we will go to the R plus 1, you can say, or I plus 1, you can say that, right? If this is I, this is I plus 1. If this is R, we can R plus 1, right? We can say that. So we have to go and in the particular index itself, we can also say either we'll move on the particular index and we'll find the minimum. Let's suppose we are finding here, we will get in the second row, and we'll get what? We will get the very first element is minimum. We'll move to the next row and we'll say, okay, let's traverse over this array and we'll find, okay, what we have. So in the second we are finding the one, the minimum one. Okay, like this means we have to find the minimum and we have to do the sum of all and we'll return the answer. So the question is saying that for each step you may move to the adjacent number of row below, as I told you, and more formally, if you are on index I, the current row, we can say that, so you may move to either I or I plus 1 on the next row. This is very easy problem, but you have to understand that you were already understood how the recursions work, right? If you know the recursion, right, means the DFS, you know, right? So this is very easy problem. We'll understand how to implement it. Okay, little changes will be there, so you can understand, but don't think that this is a list we have given. We'll get one list at a time. Let's suppose how we'll get we'll make a for loop and we'll say okay, this is our triangle. So from this triangle we can get a each row we can get, right? And we can take a row and we'll say, okay, after this what we will do for each row, we'll use arrays dot sort and we'll write what the row dot to array, we can say that, and we know that this is already converted into the array. Now just you need to we'll take a minimum, let's suppose mean, and we'll mean sum, we can say that, and we'll say plus equal to the what you call the row dot get at 0, because we have sorted it, right? And we'll define this here outside. Let's suppose for a people or a student, he is very naive, so he can say, okay, the naive approach will use like this. We'll start from 0, let's suppose, and finally we'll return the mean sum. But guys, this will not work. Why it will not work? Let's suppose we are already choosing every time the we have sorted the elements, right? And we are getting the all the time from the get at 0. So each time what we are doing, like it's simply takes the minimum element, we can say, from each row after the sorting, and it sums then, right? So that doesn't respect the, you can say, adjacent constant of this LeetCode problem that we have given. So let's understand this is a bug, right? And why this code will not work, because after sorting, right, we are doing what? We are converting into 2 array. So sorting row dot to array doesn't sort the original list that we have here. Okay, this is not doing that. It sorts a new object. When we create this one, right, it internally creates a new object, new Java object array. Okay, so even that the line is effective, right, but it is inefficient, right? So even if you did the sort of the list, picking the minimum element from each row independently ignores the rule that you can only move to the adjacent number to the next row. So the minimum overall of a row might not be reachable by a valid path. Understand? So if you submit this will not work. Okay, Let me remove this one and let's go by the what you call the recursive approach. So in the recursive approach, what we are trying to do here is we will explore all the paths, right, using the recursive, right? We'll not use the DP, but very first we'll go with the recursive approach, right? So the recursion solution that does not use the dynamic programming or memorization, right, and it recursively explore all the possible moves from each position, and it will return the minimum path sum. So this is easy to read, but note it's an exponential time in the row. Let's suppose we have offense care, right? At that time it will be slow for the larger triangle. So let's very first understand through this one. So what I will do, let's say we have the triangle we have given, so I'll say okay, right, if we'll say triangle, let me copy this one. So we'll say okay, triangle, if triangle is equal to null, right? Or we can also say if it is empty. So triangle dot is empty is a method, we can call it, and will return in this case is nothing but 0, that we have minimum is 0. This is the very first base case, we can say that. After that, let's suppose we have a method is a recursive function, and that function start from 0 0 index, right, and it will go to the all the what I'm trying to say, if this is 0 0, right, suppose it will start from here 0 0 index, this is I and j, and it will keep moving ahead, will reach to here. Let me show you how. So let's suppose for example this case, right, let's suppose I'm saying there is a grid, right, okay, or we can take here itself, don't worry. So this is our, let's suppose a type of grid we have, okay, and each grid contains the element like this. So if you segregate this, it will look like this, okay, means we have like these elements we have given, right, for each row. So there will be one I that we are traversing this side, and another is j, right? So the very first this cell will call is 0 0, we know that, and will come here is let's suppose if this is m and if this is n, row and column, right? So we can say okay, m minus 1 and n minus 1, this is the last grid, we can say. Similarly, we know all the cells what we will represent in this one, okay. So for now let's understand, come back to here. So what I'm trying to say here, that we will start let's call the recursive function, I'll give the name as a DFS recurse, okay. So this function, what we need to do, just pass the triangle that we have, we don't have, okay, let's copy this one, okay. So this triangle will use, and we'll say okay, we'll say 0 and 0, means I want to start traversing from 0 0, index 0 0. So we have to create this function, right? To create this function as a helper function or recursive function, what you need to do, we'll say okay, let's write a private, it will return what, integer. So we'll say okay, integer, and give the method name, right? This is what we have, and this is the body, we can say. So we know what is triangle is, we know that this is our triangle, so we write the triangle here, okay. We know that this row and column we have here, right? So we'll say okay, int row, and we'll say int column, okay. This is what we have given. Now what we need to do, we have to implement this function, okay. So let's write, we'll say okay, very first we'll find the size of the array. Let's suppose this is our the triangle that we are talking about here, there will be size, right, dot get the size, we can just pass the size, okay. This is a array list, so we'll use size. If it is array, we'll say length, so we'll say int and get the value, okay, and we'll get the value how, we'll say okay, this is our triangle at get row, there will be some row will be there, right, we are passing the row as you can see up, and at each row there will be some column, right. So we'll say okay, call get, and we'll say add the column. So add this row and column will get one value, that is called val, right? Value at the cell, you can say. So very first we'll check if the let's suppose this is the very first, or only one row is there, right? Means this is the last row we have. In that case, what we need to do, right? So let's suppose there is only one row is there. Row is nothing but equal to the length minus 1, right? Means there is only, this is the last row itself. At that time we should return the value that we have here. Okay, will not do anything, just that value will return, right? Because there is only one cell. Okay, now we should explore, now we'll say explore both adjacent, right? Adjacent but position. What are the position is there? In next row, in next row. So if you want to find in the next row, if you want to go for the exploring the next row, how we are going to find? Means this method we need to call, right? That we were calling here. Okay, so we'll say, okay, for getting the left path, right, we will call and we'll pass here. Okay, this is our triangle. We know that previously we have passed the row, so this will become what? Row plus 1, right? And we are not changing the column this time, right? We will use the same column here. Okay, so this is called when we go for the left path, right? So row plus 1 will do, and we'll just increase one row, and rest of the thing will be same. Similarly for the right path, right? We know that why we have taken left path, right path, I will explain a bit. So now we'll take the right path. R should be a small because this is variable. Okay, so here this time row and column both we will increase. Okay, this is what we will do, and in the last we'll return what? The current value what we have plus minimum, which is coming from left and right, right? So we'll say there should be a math dot mean, and we can pass two things. What? The left path and the right path. What is coming from the left and right path? Let me tell you what is I'm doing here. So let's suppose you are at here. Give me 1 second. Let's suppose you are at here, right? Means you are at I. Okay, and this is you are at row 0 and column at 0, right? Very first. Then we are going for the next row. This is called I plus 1. Fine. So when we are going for I plus 1, means the same function that we are taking here we can call here, right? So we'll say, okay, this time this will become what? Row plus 1, but the column is remains same. So we'll come here and we'll check the same column, right? But if I want to check this one, right, what we need to do? At the same position we'll say row plus 1, and this column will get increase plus 1, right? So this is what we need to implement. I hope you understand. Similarly we'll go for the next row and we'll start what? Row plus 1, and similarly in other case this is called the left part, and this is called the right part. Means for the very first element, if it is 2, there will be 2 elements, 3 and 4, right? So this is called left and this is called right, right? So again from here we have to traverse either this side or this side, right? We can take similarly for this, we can take like this, not 2 3, either left and right. Similarly for this, left and right. Means if you observe, the very first you got how many elements? 2 elements. Then we got left is what? 3. Then you got right is what? 4. Now again for the 3, what you have? We have 6 and 5, right? Then for 4, what we have is 7. This is not here we have null, so we can ignore for now, right? Similarly, when we go to the next level, right, let me clean it, or you understand, right? You understand clearly, give me, or you can change the color. Okay, so for the year, for this one we'll go for 2, for this one we'll go to for 2, for this one we'll go for 2, right, like this. So here we'll get what, 4, 1, 8, 3, and this is both are null, null, null. Understand? So for each time, if we are, let's suppose for this case, if we go for all this path, this is nothing but what? This is called left. This is your left, and this is your right. Right? This is your left path, and this is your right. So again, if you come here, if you are ignoring this one, for this row, this is become what? Left, and this is become right. Like that, we will keep moving ahead and we'll find the left and right. I think you understood, right, here. So let's suppose now if I'll submit this, will it work or not? Let me show you. Right? So it works, right? It works. As you can see, all the test cases are working fine. There is no error. Understand? Or if I'll say like this, if I'll run the test results, we can see here, as you can see, the test results are working fine, right? Both expected working fine, but it will not work because it is giving the time limit exception, right? So if we want the better performance for the real submission, right, it means we have to memorize these things, right? We are going for the calling. You see, you have seen this one, right? Means let's suppose if somebody already calculated this part, right, if he is going to calculate for this path, right, this subtree, let's suppose this is the very first subtree and you have calculated the sum, then you are going for calculating the all this path, then you don't need to calculate this again. Similarly, if you are going for the all the big one, right, the parent one, means you have to memorize the previous that you have calculated. Means we have to memorize the recursive version of this problem statement, we can say that. Okay, so I can show you the memorized recursion version, which is DP, or you can say the dynamic programming, we can say that, right? So it will take the bottom up approach, right, and from the bottom approach we will calculate all the times the value for the left and right, which will give you the O of 1 as a space, right? But this will work very perfectly. Okay, let me add here something. So currently this is giving O of n square, because again we are calling the recursive this one. This will go again, it will find the another one, right? Means we are calling again, so it will take O of n square in the time complexity. Okay, let's talk about how we are going to implement the DP here. Okay, so very first we know that this is what we have given, right? Means we write the if it is not empty, right? After that, what we will do, let's suppose I'll take the size here, okay, for this array. Okay, so what we will do, we'll create a, you can say, memoize 2D array, right? Let's call how we will implement. We'll say, okay, this should be int, and we'll say is a memoization. Okay, so this is our memo table, and we'll say, okay, we'll store the calculation here, right? Okay, let's write first new, and then we shall write int, and here we'll pass n that we have calculated, n into n. We can say if 3 elements is there, is total calculation will become what? 3 into 3, right? Means 9. Okay, if 3 cell we have, means 3 into 3 we have to calculate. Okay, so initially we should fill some value here. Let's call to understand that this is calculator or not calculator, right? For that, to track the it's a calculator or not calculator, let's say, or traverse or not traverse. Let's say we have int I will start from what? 0, and we'll go I should be less than what? N, and I plus plus. Here what we will do, we'll say, okay, arrays dot fill we will call, and we can fill all the cell. How? For memo at I will get 1D array, right? From the 2D array we'll get the 1D array, and we'll say, okay, integer dot pass the mean value. So this is the minimum infinite value will pass of an integer value. So if we'll check if this is contains the mean value, right? It means what? It is already calculated. Okay. If it is containing, so this is not calculated, because if we are filling, if it is containing the mean value means it is calculated already. Okay. And then similarly we'll call the DFS, a recursion function, will not do anything, just will pass one more thing, that is called the this memo table. So what we will do, we'll pass the memo, we can pass one more argument, and this part should go in declaring the function here, or method you can say, right here. Now we know that we have int n is a triangle dot size, right? And this is our having the base cases that we have written. Okay, so this time let's suppose we have the value here, and we are getting the triangle dot get row and get column, and we are getting the value. Okay, and we will return in the case of base case. This is nothing but your base case, always remember. Okay, now think, if you are getting this well, right, and if it is not at the end, means there is only, this is not at the end of the row, right? In that case, what will happen? We will check the value first. Let's talk about what. So for now I'll close here. Okay, so let's suppose very first we'll check, okay, if everything goes good, we'll say if memo contains this row or column some data or not. If it is doesn't contains the integer value that we have talked about, right, this integer value, if it is not the mean value, if it is not the mean value here, right, in that case it should return some value. We don't need to calculate because this is already calculated. So we'll say, okay, return this value, the memo value. We don't need to recalculate, just give from the memo table. In the further cases, what we will do, we know this is our left and this is our right, and we are calling the DFS, right? So we just, okay, so we missed this thing, so we will add one more thing, is memo, because we have added this one, right? Let me show you. After writing this, remember I have also called here when we have started the traversing, right? When we are starting the traversing through the recursion, we have to also call wherever we calling is. Okay, so this is very simple, we don't need to explain much here. But how we are going to find the mean, right? Let's suppose if it is not calculated, right, means it is already having mean value, it means we have to update. So once you find this mean value, right, you have to update this one. So how we are going to find the mean value? So this is our thing that we will return. So very first, let me write here, we'll return this one, right, and we'll cut from here, right, and we'll store here. This is what we need to do, means the value plus math.mean, and we'll take what from the left and from the right, what is coming, right, what is the minimum value is coming from the left path and for the right path. So that we will store at the mean value, and rest of the thing what we will do, will return memo, will return here. So guys, DDB is not a big thing. If you know the recursion, it's very easy. Okay, let me submit. Okay, so yeah, as you can see, all the test cases are working fine, right? So this time we have to check that this is working or not. Let me submit this. So as you can see, this is working fine perfectly. Okay, so in case if you have any doubt, please ping me in the comment box and write the any suggestions you have. Okay, and please support Excel Funda by liking and subscribing this channel, and if you have any requirement, let me know in the comment section. You can get the WhatsApp number and you can call me and we can have a discussion there. Okay, thank you guys, thank you for watching this video. I'll see you in the next one.